All right. So you really need to pay attention because this is not hard if you listen to what I'm saying. It's hard if you just read this and I said, hey, work this problem, right? Doesn't that just look overwhelming? It does. There's a lot of words. The picture doesn't make sense. Okay, so listen to what I'm saying. An architect draws plans for extending a rectangular deck. Okay, so imagine that you have a deck on the back of your house. Here it is right here. And your parents want a bigger deck. Okay, they want to make the deck longer, but they don't know how much longer they want to make it. So that's why this is here. And that's why there's a variable x. So your parents say, well, I don't know. Do I want it to be 2 feet longer or 3 feet longer or 10 feet longer? I don't know. Okay, but they know they don't want it to go any higher. Does that make sense? So this represents all of the new part that you're putting on. Okay, so they give you this expression. So before we look at that with this, can you tell me, how do you find the area of any rectangle? So let me give you some easy numbers. Let's say 2 and 5. How would you find the area of that square? Rectangle. Length times width. So the area of this true would be 10. Okay, make sense? Okay, so now let's look at this. What operation is going on between this and this? Multiplication. So let's look at this. Where does this number come from?
3.7.
I know it's 3.7. Where does it come from? Yes, you can call it the height of the deck if you want, or you can call it the width of the deck. That's fine. Okay, where is this coming from?
The length and the extra width.
Yes, isn't that this? Because let's think about this. You have your original deck at 4.5, and you want to add more length to it, but you don't know how much, which is why you're calling that x. Does that make sense where all those numbers are coming from? Okay, so it says, what does each factor in the expression represent? That's what I just told you. What was this?
3.7.
The width. What is this? What is this? The length. Okay. What is it when I put these two together? Yes, length times width, which is the areas of all of it together. Okay? All right, so now what your job is to do, I want you to start this next part. I want you to use the distributive property and expand it. So that's your job right now, and I will help you with the next part. Go. All right, so when we expand, we take 3.7 times 4.5. Is that 16.65? Am I right? Okay. We keep the sign plus, and then 3.7 times x is 3.7x. Okay. Now, here's where this part gets a little tricky again. So you really got to think about what we just did. Okay. What does each term of the new expression represent? So let's look at this one right here. Okay, now, here's the easiest thing to do. Think about where this number came from. How I got this number is I multiplied this by this. Raise your hand and tell me, what does that number represent? Look what I did. Look at your picture. Look at the number you got. What does that number represent? I said, raise your hand and tell me. True. Nope, not the width. The area of the original. Very, very good. Because here is height, here is your base, right? Base times height is this number. That number right there. Okay? All right, so let's try the next part. What does this represent? And look at what you did, and look at the picture. What does that second number represent, Jake?
The area they want to add on.
The area they want to add on. Very good. Because this right here is the height, which is 3.7. This is the bottom, if you multiply the two together. Now, what do you get if you add this whole thing together? What does that tell you?
The whole width of the entire.
Not the whole width. Nope. The whole area after you put on the new deck. That's what it would tell you. Okay? That the whole, if you added all of it together, if you knew what x was. Okay? Shaylin, you should hear it. All right, let's try the next one, and maybe this one will seem a little bit easier. All right, for your birthday, you plan on buying 2 cupcakes for each guest. There, guys. Okay, and 5 additional cupcakes is extra. So think about what that means. Okay, so each kid is going to get 2, show up, so I'm gonna have a few extras. Okay. Cupcakes cost $2.25. Let X represent the number of guests you invite to your party. Use the expression below. What does each factor of the expression represent? So tell me, there's three numbers up there. Tell me what one of those three represents. Tell me what one of those three, Jonathan. Which number? 2.25 is the cost per cupcake. Very good. That's what one of them is. Somebody tell me another one. Haley. Is represented by what? 2x represents 2 cupcakes per person. Okay, so now we have the 5. True. 5 extra cupcakes. Very good. In case extra people show up. Very good. Okay, so what does that whole expression represent then? No? Jake?
The amount of cupcakes.
Nope. Morgan? So what is just that expression? What is that? What's that? It says, what does the expression represent? What is that going to represent? The total cost, right? So however many people show up, that will represent my total cost. Okay. So the next part, use distributive property to expand. So right now, everybody go ahead and expand that. All right, so let's see what you have. 2.25 times 2 is that 450? Okay. X plus 2.25 times 5 is 1150? No, it's 25? Okay, so now it says, what does each term of your new thing represent? So what does this first part mean? What does 450x mean? What does that represent? Think about it. Everybody think. Megan. How much did it cost to buy the 2 cupcakes? Okay, so that's the cost per person. That's the cost per person. Okay, what does the 1125 mean? True. Yeah, this is your additional cost. Okay, so what would you use this for? This would be like, I have a budget. Your parents said you can only spend $50 total on your party. And you're like, wow, if I only have $50, I probably don't want to spend $11.25 on extra cupcakes. Or maybe I decide that $4.50 per person is a little too much. I don't want to spend that much, and I would cut it down. Or maybe it means I want to spend that much, but I might not be able to invite very many people. That's what that equation would help you decide. All right, very, very good. Okay, we are done.